Alright, this is some of your notes for the intro parts to Chapter 7. In Chapter 7, we are going to deal with radicals. So this intro section, before we actually get to the chapter, we're going to learn how to do some operations with radicals. And in this particular video, we're going to learn how to simplify radicals. Okay? Now, we're only going to be dealing with square roots in this chapter. In this whole class, in geometry, we're just going to deal with square roots. When you get to Algebra 2, then you can deal with cube roots and fourth roots. Things change a little bit. It doesn't change the difficulty of the problem, but in here we're only working with square roots. Now, when we're working with a square root, there's two parts to a square root. The first one is the radical sign, and the second one is called the radicand. Alright? Now the radical sign is this check mark looking thing, and the radicand is whatever is underneath. So in this case, what we would normally call the square root sign, it's called a radical sign. And then B is our radicand. It's what's underneath that square root sign. Now, like I said, we're going to be dealing with square roots, so it's really important that you know what your perfect squares are. And the majority of people can figure these out. If you don't know them, you can put them in a calculator, but I would expect you to know them off the top of your head, at least 1 through 12, okay? So we're going to fill in this chart with all of our perfect squares. We're actually going to go to 15, but again, I want you to know through 12. Well, 1 squared, that's really 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and 6 times 6 is 36. Those are the ones most people remember, that first column. If I asked you what 6 squared is, most people can rattle those off. When we get to the second column, they get a little harder. These are ones people tend to forget. 7 squared, 7 times 7 is 49. 8 times 8 is 64. 9 times 9, 81. 10 times 10, this is an easy one, 100. 11 times 11, 121. And 12 times 12 is 144. Okay? So that's what I expect you to know in class, for class. I expect you to know 1 through 12, the perfect squares. Now I'm also going to give you 13 squared, 14 squared, and 15 squared. And if you can remember these, that's about as high as we'll go in this class. 13 squared, 13 times 13 is 169. 14 times 14 is 196. So all you do is flip those two numbers, the 6 and the 9. They flip to become 96. And 15 times 15 is 225. Okay? So those are your perfect squares. Now, again, you need to know those because in this next part where we look at these examples, we're going to figure out the largest perfect square that goes into a lot of these. Okay, and that's how I want you to simplify these radicals. It'll make more sense when I show you some examples. So let's get into that. Simplifying the radical here. First example is the square root of 16. Now, you could put that one in a calculator. You will get a whole number answer. More often than not, you won't. And I want radicals in your answer. I do not want a decimal. So what we look for is we look for the biggest perfect square that will go into our radicand, into 16. If we look at this example, 16 is actually in our chart up here. It's one of our perfect squares. So we can rewrite it as 4 squared. The square and the square root cancel each other out, and our answer is 4. And that's how we would solve this problem. Now that's an easy example because we get a whole number answer. The radical cancels itself out. Let's look at this next one. Square root of 121. Well, this is the same idea. We want to find the biggest perfect square that goes into 121, and it's actually already in our chart. It's 11 squared, so we can rewrite it. The square and the square root cancel each other out, and we're left with 11. Okay? Those are easy examples. When we get to something like the square root of 98, 98 is not in our chart, so this is where it gets a little different. We want to figure out which one of the numbers in our perfect square chart goes into 98 evenly. And we can go through, we can try them. We can do 1 times what gives us 98? 98. Neither of those are in our perfect square chart. 4 times what? And we continue to do that until we figure out a number that goes in there. The number that does go in there is 49. It's 49 times 2. That's the biggest perfect square that goes into 98. And I figured that out by going through my chart and testing my numbers to see which one went into to 98. Now I'm going to circle 49. Most of you can do this in your head. The square root of 49 is 7. It's just like these first two examples, but I'm not going to rewrite it at all. Square root of 49 is 7. 7 will go out in front, and that 2 is not a perfect square, so it stays underneath. And there's the answer to our problem. So let's talk through our steps here. We circle the perfect square, we root it, and that number goes out front. And then the non-perfect square stays underneath. It stays in the radicand. Okay? So those are kind of our steps. We want to figure out the biggest perfect square. We want to circle it. That square root's going to go out in front. The non-perfect square stays underneath. Let's look at another example. We've got the square root of 112. Okay? Well, we need to figure out what the biggest perfect square that goes into 112 is. So I'm just going to start going through my chart. Well, 1 goes into 112 112 times. That's not going to help me. Let's try 4, because 4 is the next number in our table. I'm going to do 112 divided by 4, and I get 28. Well, that looks good. That went in there evenly, so this is a possibility. I want to make sure, though, that 4 is the biggest, so I'm going to keep going down my list. 9, I'm going to do 112 divided by 9. That gives me a decimal, so that doesn't work. Let's go to 16 now. 16. 112 divided by 16, and I got 7. Now I can stop there because I know 7 is a prime number. It doesn't contain any perfect squares. So that tells me 16 is my biggest perfect square. So I can break it down, 16 and 7. Again, I'm going to circle that perfect square, circle 16. The square root of 16 is 4, so 4 goes out in front, and 7 stays underneath. And there would be the answer to the problem. Okay? Let's look at one more example. This time we've got the square root of 180. So we're going to figure out the biggest perfect square that goes into 180. I'm actually going to not pick out the biggest perfect square, and I'm going to show you what happens. I know that 4 times 45 will work. Okay, so I'm going to try this. 4 times 45. 4 is not the biggest perfect square. I'm going to circle 4. Square root of 4 is 2, and I am left with 2 square roots of 45. Now, if I didn't take the biggest perfect square out, I should be able to break down my radicand again, and I can, into 9 and 5. 9 is another perfect square. If I can break it down a second time, and you always want to make sure that if you can't break it down a second time. If I can break it down a second time, that means I didn't take the biggest perfect square out. Okay, all that means is I have another step, and that's okay. I would really like you, though, to look for the biggest perfect square, because it will save you some work. If you didn't take it out, though, we would have to continue this problem. I would take the square root of 9, and the square root of 9 is 3. Now, out in front, I already had that 2. My 5 stays underneath. If I take more than one thing out in front, I multiply them together. So I would get 6 square roots of 5. Okay? So I need to multiply. If I already had something out in front, or I take 2 numbers out in front, I always need to multiply them back together. Alright? And those are your examples on simplifying radicals. If you have any questions, rewatch the video, and if you still have questions, bring them to class next time.